inequalities. As we're going to have to solve linear inequalities pretty much the same way we had to deal with linear equations. Let's talk about the steps for solving an inequality. The first thing we need to do is we need to identify the variable that we're solving for. The second step is we're going to have to solve by isolating that variable exactly the same way you would with an equation. And then finally, we're going to have to use the symmetric property, if necessary, to rewrite the equation with the variable on the left-hand side. What do I mean by that? Well, if we have, say, 3 is less than or equal to x, that's not really set up in the way we talked about for graphing it. So what we need to do is now turn the entire thing around, right? So now it's actually just, it's like the symmetric property for equations, but now you also have to turn around this little symbol as well. So we're going to write this as, we want x on the left-hand side, and instead of less than or equal to, I want to change that to greater than or equal to, and then the 3 is going to go right here. So we're just going to switch everything. It's kind of like walking around and looking at it from behind. Alright, so taking a look at first example, we have 3 is greater than 2x minus 5. And we would start solving this exactly the same way we would with an equation. I'm going to draw a line because I know it helps a lot of you. So the first thing we need to do is add 5 to both sides of this inequality. Now, the minus 5 and the plus 5, these two we're going to add to 0 or cancel each other out. And then we have 3 plus 5, and that's going to become 8. And 8 is still greater than 2x. Oops. Our next and final step for solving is going to be dividing both sides by 2. The 2's, of course, will divide to 1 or cancel each other out. And then we have 8 divided by 2 is going to give us 4 is greater than x. So like we just talked about, now we're going to need to use the symmetric property to turn this around so the x is on the left-hand side. So we're going to write this as x is, now instead of using the greater than symbol, the alligator still is going to want to eat the 4, for some of you, and so we have x is less than 4. And now it's set up for us to graph. So again, we graph it by writing the 4 in the middle of our number line, values lower than 4 to the left, values greater than 4 to the right, putting a circle above 4, and then covering all of the values that are less than 4, or following the arrow. And a new step for us is going to be checking one of our solutions, because any number from this side of the line is, any number from over here is a possible solution now. So we can pick any number and check to see if it works. So I'm going to actually check 2 different solutions. Let's say our first one, we will pick, let's check 3. So putting it right back into our original inequality, we have 3 is greater than 2 times 3 minus 5. 2 times 3 is 6 minus 5 and we're still saying that 3 is greater than that. 6 minus 5 is going to become 1, and 3 is greater than 1. This works, so 3 is a solution. That works out fine for us. And we can go ahead and check. I want to see if I want to see what happens when we actually plug in 4, since now we're just talking about greater than, not greater than or equal to. So let's see. Pick ourselves a new color. All right, so let's say 3, and again we're checking it in our original inequality. So 3 is greater than 2 times 4 minus 5. 2 times 4 is 8 minus 5. That's going to give us 3. Is 3 greater than 3? Nope. So this number is not a solution to this inequality. So we have to reject this one. And the same thing, something similar would happen if we checked numbers like 5, 6, and 7. Let's take a look at another example. Okay, we're coming up to an example of a special case where we talk about multiplying and dividing both sides of an inequality by a negative number. Let's see, we have negative 4x is greater than 12. So to solve this inequality, we would divide both sides of that inequality by negative 4. Negative 4 divided by negative 4 is going to cancel out or divide to 1. And 12 divided by negative 4 is going to give us negative 3. So on our left-hand side we have x. On our right-hand side we have negative 3. But since we divided by a negative number on both sides, we're going to need to switch this symbol of inequality. Let's see what happens if we didn't switch it. Well, first, let's go ahead and graph. We have x is less than negative 3. So to graph this, I want to put negative 3 in the middle. Numbers lower than negative 3. So be very careful when you set up your negative number line, because numbers lower than negative 3 are going to start looking like negative 4, negative 5. It's going to almost look like you're counting backwards, but they're negative. And we have, on the right-hand side, we'll have negative 2, negative 1, and 0. And we want to say it's going to be an open circle because this is just less than, and x is going to cover all of the values less than negative 3. Now, to prove it to ourselves, we would have to go back and check one of our solutions, so either 6, negative 6, negative 5, negative 4, or anything lower in our original inequality. So let's go with negative 6. We have negative 4 times negative 6, and I'm saying that that is greater than 12. Negative 4 times negative 6 is going to give me positive 20. And is that a greater number than 12? Yes. So negative 6 is part of our solution set. Let's take a look at what would happen if we had not switched the symbol, and if we went with, and I'm going to stress it by putting it in red that this is not true, but let's just see. If we had not switched the symbol, we would have ended up with x is greater than negative 3. A number greater than negative 3 would be 0. Checking that in our original inequality, we have negative 4 times 0 is greater than 12. Negative 4 times 0, what's that? 0. So we're saying 0 is greater than 12. Is that right? Nope. Absolutely not. So whenever you divide or multiply by a negative number on both sides, it's very important that you remember that it's on both sides. If it's in the process of solving the inequality, then you just have to flip your little symbol of inequality over.